All right, today we're going to tackle a math concept that is super useful, but let's be honest, can be a little tricky sometimes. We're talking about how to find the lowest common multiple, or as you'll often see it, the LCM.
But before we get bogged down in a bunch of definitions, just take a look at this. What's the smallest number that's a multiple of both 6 and 10? Think about it for a second. What's the first number that shows up in both the 6 times table and the 10 times table?
So, if you were already thinking about times tables, you are exactly on the right track. That number you were just looking for, that's what we officially call the lowest common multiple. It's just the smallest number that you can divide all of your starting numbers into perfectly. Okay, so how do we actually find this thing? Well, there are a couple of really good ways, and we're going to start with the one that probably makes the most sense right away. I call it the straightforward way, just listing out the multiples. The process here is super simple. It's really just 3 steps. First, you just write out the times table for your first number. Then you do the exact same thing for the second number. And finally, you just look at both of your lists and find the very first number that they have in common. That's it. Let's go back to our original problem. So, here are the multiples of 6, and here are the multiples of 10. As you scan across both lists, what's the first number that pops up in both? You got it, it's 30, and that's our LCM. Simple as that. Now, I gotta give you a quick but really important warning. A shortcut a lot of people try is to just multiply the two numbers. So 6 times 10 is 60. And yeah, 60 is a common multiple, but it's not the lowest one, right? The key thing here is remembering that multiplying will get you a common multiple, but it won't always give you the right answer. The listing method, on the other hand, that one gets you the correct lowest one every single time. So this listing method is great. It's clear, it's easy to follow, but it has one pretty big weakness. It can get very, very long. And this is where you really see the problem. I mean, can you imagine trying to find the LCM of 28 and 42 just by listing them out? You'd have to write out the 28 times table and the 42 times table. How long would that take before you found a match? You could be there for ages. Clearly, we're going to need a better way for bigger numbers. And thankfully, there is a faster way. It's a bit more advanced, but it's so powerful. It uses a number's basic building blocks, its prime factors. Now, this might look a little more complicated, but stick with me, because the logic is rock solid. First, you break each number down into just its prime factors. Then, you look at both of those lists, and step 3 is the absolute key. To avoid counting things twice, you only count the factors they share one time. Then you just multiply all the factors you've collected together. Okay, let's try this with our trickier numbers, 28 and 42. So first we break them down. The prime factors of 28 are 2 2s and a 7. And for 42, we've got a 2, a 3, and a 7. Now for the most important step, you want to see what they have in common. So they both have a 2 and they both have a 7. Those are the shared factors. We only need to count that shared 2 and that shared 7 one time to satisfy both numbers. So to build our LCM, we need to gather all the ingredients. We take the shared factors we found, the 2 and the 7. Then we grab the leftovers. There's another 2 from the 28 and a 3 from the 42. We multiply all of those together, 2 times 2 times 3 times 7, and we get 84. And that is our LCM. Way, way faster than listing, right? Now, look, if this prime factor method feels a little strange or confusing, that's totally okay. It's a different way of thinking. The source material actually says it perfectly. It is a kind of odd concept. The best thing you can do is just try a few practice questions, and I promise, after a little while, it'll start to click. All right, you ready to see the true power of this pro method? Let's really put it to the test with an example that would be almost impossible to do just by listing. We are going to find the LCM of 132 and 420. Whoa! Okay, so first step, break them down. You can see their prime factors here. And right away, we can spot what they share. They both have 2 2s, and they both have 1 3. Those are our shared ingredients. So, to build our LCM, we take everything we need. We take the shared parts, the 2 2s, and the 3. Then we take the leftovers, the 11 from 132, and the 5 and 7 from 420. Let's line them all up and see what we get. And the answer is 4,620. That is a huge number. This just perfectly shows how the prime factor method can solve a problem in seconds that would take forever if you tried to list it out. It's just so much more efficient. So the big takeaway today is that you now have 2 fantastic tools in your math toolkit. You've got the listing method, which is awesome for smaller, simpler numbers, And now you have the prime factor method, which is your go-to strategy for tackling those bigger, more complicated problems. So now you have a really solid handle on finding the lowest common multiple. But it kind of makes you think, doesn't it? Knowing these different techniques opens up new ways to see how numbers work together. It really leaves us with a question. What other clever math shortcuts are just hiding out there in plain sight, waiting for us to find them?